The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. Today we're going to take a look back at the past year in science and see what remarkable new developments and potentially terrifying conclusions that 2012 had to offer. And of course, I have a brilliant panel here today, some past guests that we can never get enough of. David Dobbs is the author of Reef Madness, Charles Darwin, Alexander Agassiz, and the Meaning of Coral, and the #1 Kindle single bestseller, My Mother's Lover. He writes features and essays for publications like The Atlantic, The New York Times Magazine, National Geographic, The Guardian, and Wired. Hello, sir.
Hello.
Maryn McKenna is also a blogger for Wired, a columnist for Scientific American, a senior fellow at the Schuster Institute for Investigative Journalism, and the author of Superbug, about antibiotic resistance and beating back the devil, about the disease detectives of the CDC. Welcome back, Maryn.
So happy to be back. Thanks.
Brian Switek is a freelance science writer and paleontology blogger for National Geographic. He's also the author of the book Written in Stone, about great transitions in the history of life on Earth, and the forthcoming My Beloved Brontosaurus, about how paleontologists are drawing out the secrets of dinosaur lives. Brian, great to have you back, and congrats on your move.
Thank you very much. It's a pleasure to be here.
And Maggie-Koerth-Baker is the science editor at BoingBoing.net and a science columnist for the New York Times Magazine. She's also the author of Before the Lights Go Out, a book about electricity, infrastructure, and the future of energy. Welcome back, Maggie.
Hi, thank you.
So we have a lot to talk about. Let's start with David. Now, you have been doing a lot of research on genetics, and there seem to have been some shifts in the field?
There certainly have. This is something that's ongoing. I'm writing a book about behavioral genetics, so my framing is a little bit leaning that way. But across the board, the whole field, they're scratching their heads. That it was hoped that the whole genome project, once we had the entire sequence of the human genome, that a lot of things would just kind of pop out of the data. If you could genotype several thousand people, you'd start to see which genes caused this kind of cancer, which genes caused this kind of behavior, which genes caused all sorts of things. And there's been a lot of frustration that we are finding very few genes of strong effect. And everyone's sort of trying to figure out what comes next. There's been a lot of attention to epigenetics. That may be part of the answer, but it's kind of a cool stage because they've done this great big thing. But even the smartest people, while they're continuing to work the whole genome approach and getting some important results, just not that many, there's a feeling that there's some other layer of dynamics here that is making a big difference in what genes do and how they work that we haven't been able to ferret out yet. And there's a lot of ideas bouncing around, but mainly kind of a groping in the dark at this point, which is frustrating for a lot of people, but it's also a time of great opportunity, because if somebody can find something that means something extra, it'll be a big deal.
Well, what are the criticisms of focusing on whole genome research?
There's a huge, wonderful argument for focusing on whole genome research because now that we can sequence individual genomes quickly, we can compile thousands of genomes and analyze them to look for effects. And the more you analyze, of course, the bigger the chance that you will start to see single genes, or at least kind of groups of genes, if you will, that do have significant effects. And this has led to some new really valuable insights about how particular diseases arise. There's actually been some new genes identified for rare diseases and the beginnings of cures for some of them. So great value there, but it's hard to say what the biggest criticism is. But one thing that a lot of people are saying is that there's not enough attention to how the genome interacts with the environment to explain things. There's been a big body of work done before. It's called gene by environment interactions, which looks at what a particular gene, how it will behave only in a certain way when it's faced with a certain type of environment. one problem with the whole genome approach is since it emphasizes huge numbers, it's difficult to do genome by environment studies because compiling environmental measures and particular outcomes to look for, that's a lot more complicated. It's hard to do at large scale. There's also kind of a cultural split within the genetics community between the gene by environment people, which happen to be mainly candidate gene, single genes researchers, and the whole genome researchers. And as they start to mix more and figure out a way to look at whole genome and environmental issues, I suspect we'll start to see some interesting stuff.
So is there a bit of a conflict right now between the whole genome people and the candidate gene studies then?
Very much so, and a lot of a bit of animosity there. The candidate gene people, so this is someone you would pick a particular gene, like the short version of the serotonin transporter gene that's been associated with depression, and then you would look at two variants of the gene. You would look at how the different variants affected people's fate, depending on what kinds of environments they faced. And these people kind of owned a huge portion of the genetic budget for, say, 1990 roughly to about 2005. And in the meantime, they decoded the whole genome, and the whole genome people said these gene by environment studies, there's all kinds of problems with them, and they had some very legitimate criticisms there. But their basic problem was the numbers aren't enough. These are small studies. A big one would be 200 people. A huge one would be 500. And the whole genome people said you're not going to get effects showing until you're doing thousands of people. So there was, when there's a paradigm shift in a field where a whole new methodology comes into play, usually the people who kind of owned the dominant paradigm before aren't terribly happy about it. And the people who are creating the new paradigm tend to want to make the most of it. It's just natural. So there's a kind of turf battle going on. And the whole genome people in funding terms are winning that struggle. They are capturing most of the increasing amounts of the budgeting for genetic research, and the candidate gene people are having a hard time getting money for the kind of studies that they got money for very easily 10 years ago. So there's a lot that discourages a free flow of cooperation between those parties. I don't want to overplay the schism, but it's there. And if they can mix their thinking a little more, I think it might lead to good things.
Maggie, you wanted to talk a bit about climate change.
Yeah.
What happened in 2012 relating to that exactly?
What I've really seen in 2012 is both a realization among the public of effects of this actually happening, like that people are kind of starting to really get the idea that we're not talking about stuff that will happen 50 or 100 years from now. We're talking about stuff that happens now. You saw people actually sending, I think, large shipping vessels through the Northwest Passage, right, this year. And that is, I think, something that's concerning and something that's noticeable. You also had several big weather disasters. And I think that that's the other big trend that I've noticed is people trying to figure out how to talk about this. And I don't think that we're very good at that yet, because we have a really good way of what climate change does on a global level. But we don't have really good ways of talking about and helping people understand what it does in their local community. And that's really what people want to know, right? Like, you want to know how is this going to affect me personally? And it's not really easy to explain. I think one of the biggest problems that we have is that, the fact that climate change can cause heavy snowfalls in one place and a drought in another place. And from a certain perspective, it starts to sound like you're just saying, well, everything that happens with the weather is caused by climate change. And I've actually had some commenters on BoingBoing respond that way when I've tried to point these things out. But at the same time, I think we're making progress because we're actually having these conversations and starting to have more people think about that this is a plurality of effects, that it's not just one effect, it's not just things getting hotter. And that's, I think, really interesting to me. And I'm not sure if that's something that other people have noticed as well. I'm curious what the rest of the people on the panel think.
One thing I think about when on this subject is we heard a lot how it's just human psychology that we tend to either ignore or at least discount future hazards, right? And
Mhm.
so up to now, it differs for individuals in different parts of the country. When it gets to the point where we can't ignore the present consequence, that's when we'll pay attention. And maybe I hear you
Right.
saying that for a lot of the country and a lot of the world, we've hit that point where now
Yeah.
it's a present threat instead of a future threat. So we'll finally take it seriously.
I think that's true, but I think that we're also it's not just that there's a present threat that we're starting to pay attention, take it seriously, but at the same time, we have this conflict of it's a present threat, but it's different threats. And so we're trying to figure out at the same time taking it seriously, but also what does it actually mean and what is climate change and what isn't. And that's a conversation I see my readers having. And I think that it's a useful conversation. I think it's something that needs to be had. But I think it's a complicated conversation. I don't think we have a really good way to talk about it without just sounding like we are, I don't know, covering our asses a little bit. It's hard to talk about things like Hurricane Sandy and say, yeah, this is caused by climate change when you don't actually 100% know. And it's not just caused by climate change, it's caused by lots of different factors. And when you actually try to talk about that in a scientific, honest, factual way, it ends up sounding like you're trying to scare people and lie at the same time.
It's interesting to me watching the conversations people have about extreme weather, particularly on social media, particularly, for instance, on Twitter, where everything's so compressed, where, oh, global warming has almost become a meme, which is sometimes used honestly and sometimes used ironically, like, oh, hotter and 110 degrees in my town today. Oh, well, global warming. Or, oh, 37 inches of snow, global warming, quote unquote. People people are having a lot of difficulty, I think, processing what you're talking about in terms of the unpredictability of the effects. That they've sort of, I think, have wrapped their heads around, hottest June in 100 years. Oh, global warming, but 3 feet of snow on the 2nd of April,
right.
That might also be global warming. Or, the Rockaways, where I must say my family is from. So Sandy is particularly upsetting to me. The Rockaways completely submerged. Oh, global warming. They have a lot more trouble. It's not a straight line relationship. Yeah. And the complexity of that, I think, is confounding enough to people that they want to sort of put it away and be ironic or sarcastic about it instead.
Living out west, I live in Salt Lake City, Utah. I used to live in New Jersey, and since moving here, it's been odd to see the clash of interests in terms of this topic, because people here are very concerned about water usage and what's going to happen in terms of droughts and climate change. I mean, last year, most of the state was in a drought emergency, and we had wildfires everywhere, much like Colorado. But at the same time, we have the state governor saying that he wants to seize all the federally held lands, many of the national parks, BLM land, and basically sink every oil well and natural gas sort of facility possible to raise state revenue. So people here are recognizing that there is some kind of future problem, but at the same time there's a much more immediate sort of interest in developing technologies that would contribute to global climate change and pollution. So it can be very difficult to argue with people still, at least in the West, about sort of future implications when they see an immediate payoff.
You're listening to Skeptically Speaking, and we're talking about the science stories of 2012. My guests are Brian Switek, who writes at National Geographic, Maggie-Koerth-Baker, science editor at BoingBoing.net, and Maryn, McKenna, and David Dobbs, both from Wired.com. Now, Brian, how is the world of the long dead?
It's doing quite well. It's coming a little bit more back to life every day.
So there were some interesting developments in 2012 in your field.
I mean, there wasn't anything specifically that I was absolutely blown away by, but the incremental sort of discoveries, adding a little bit more, is allowing us to predict things about prehistoric life that then we can then go back and test by doing further research, going out into the field, looking for stuff. One of the coolest things to me was a 30-foot long fuzzy tyrannosaur found in China. Now, since 1996, there have been a lot of feathered dinosaurs coming out of the ground, especially in the group most closely related to birds, this group called Coelurosaurs. Almost every lineage within this, including some small tyrannosaurs, has been found with feathers. And because of that, people are predicting that maybe, Tyrannosaurus rex itself was, a big fuzzy carnivore. It looked cuddly and then, bite the head off Triceratops or whatever it did. And people would argue about that, saying, well, it was so large, did it really need this insulating coat? Maybe it would overheat. But the fact that we now have a 30-foot-long fuzzy tyrannosaur out of China means that, body size wasn't necessarily a factor for this kind of ornamentation. So the addition of all these little fuzzy and fluffy dinosaurs is allowing us to sort of, predict who else might have been fuzz-covered. And the fact that, maybe most dinosaur lineages had, bristles or fuzz or feathers might go all the way back to the last common ancestor. And that ties in with another big discovery that really I found quite interesting in terms of the physiology debate. I mean, since the 1960s, paleontologists have been arguing over whether dinosaurs had a more like bird-like metabolism, whether they maintained high body temperatures, whether they had fast-running metabolism, whether they're very active creatures, or they're more sluggish, or had some really weird other physiological profile. And this discovery actually came from mammals rather than dinosaurs. The argument was that dinosaurs, as they grow, they'd have these seasonal or yearly slowdowns in growth that would deposit a line, almost like a tree ring. So if there was a dry season or a winter, they would basically stop their growth during that time, lay down this really dark band in their long bones, and then they would continue growing really fast. And you could sort of count the rings and get an idea of how old these dinosaurs were. And we also saw this in crocodiles and lizards and turtles. So people said, well, aha, they must be, just like reptiles today writ large. Well, there was a study that was done by Maggie-Koerth, where she found these same lines in herbivorous mammal bones from the poles to the equator. So this means that mammals that maintain high constant body temperatures, have active metabolisms, they're doing the same thing. That seasonality affects bone growth. So we can't use that argument anymore to say dinosaurs must have just been like big crocodiles or big lizards. Mammals are doing the same thing. So it's another indication that dinosaurs actually had really active sort of hot running lifestyles.
So is this the same process as like the rings of a tree?
I don't know enough about botany to say it's exactly alike, but in broad strokes, I guess it's somewhat similar. It seems to be like when there is something like a drought or wintertime when resources are scarce, the organism stops growing temporarily, and when the rains come back or the ecology is a bit more amenable to growth, it picks up again. So the question with dinosaurs is whether this actually represents a yearly pattern, whether this is droughts over many years, or what exactly those markers represent. But we do know, at least biologically, what's causing this.
That's very cool.
You're listening to Skeptically Speaking. We're talking about the science stories of 2012, and we'll be right back with more of that after this.
Skeptically Speaking wants you to question everything. To be a part of the discussion, call and record your question on our listener question line at Speak 73101. That's 773-257-3101. Long-distance charges may apply. Sunday nights at 6 Mountain Time, join our Ustream chat room to listen and ask questions as we record interviews live. Just click the Listen Online button at skepticallyspeaking.com. You can also email your questions and comments to live@skepticallyspeaking.com, or if you're on Twitter, tweet us at Skeptical Radio. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm Desiree Schell, and on today's episode, we're taking a look back at Science 2012. With me today are Maggie-Koerth-Baker, author of Before the Lights Go Out, Maryn McKenna, who wrote Superbug, David Dobbs, author of Reef Madness, and Brian Switek, author of Written in Stone. Maryn, you have been on the show to talk about many horrifying things, but the one that always terrifies me the most is antibiotic resistance. So let's talk gonorrhea and go.
It was a really bad year for scary diseases along a number of different axes. But the story of gonorrhea is one that I think probably touches people closer to where their lives might be. I'm trying to be very polite here. So pretty much what's happened, and almost no one has noticed this aside from public health authorities, is that over about the past 10 years, gonorrhea, that everyday sexually transmitted disease that we were all warned about in junior high health class and then kind of forgot about because it seemed treatable and not a big deal and certainly not as important as HIV, for instance, gonorrhea has suddenly, or not so suddenly, become effectively untreatable. In August, the Centers for Disease Control came out and said, guess what? We have only one drug left for gonorrhea. That's it. Then we're done. And I asked a friend who actually runs an STD clinic. I said, so when they say one drug left, do they mean and then you have to go to the hospital, or one drug left and then you have to get an IV? And she said, no, they mean one drug left and then we need clinical trials. So the story is that a little bit more than 10 years ago, people started noticing that on the Pacific Rim, primarily in Japan, gonorrhea, which had steadily over the antibiotic era become resistant to a number of drugs, which wasn't all that important because there was always another drug, it was starting to show resistance to one of the two remaining drugs. The two drugs are called cefixime and ceftriaxone, and one is given by a pill and the other is an injectable. And if you think about what it takes to give someone a pill, it's easy. You don't have to have a healthcare professional to do it. If it's the right size pill, you can give them one dose and they're done. Though all of those things that it's easy to give, you can use low cost staff to give it and it works quickly. That's the basis of all STD control around the world. They started to notice that this gonorrhea showing up in Japan was becoming resistant to the form of the drug used in the pill. And this resistance spread over the Pacific and then across the United States, starting on the West Coast, over about 10 years. And over about the past 2 years, public health authorities started really raising the alarm and telling physicians and STD clinics who were treating gonorrhea cases, you really need to start checking for this resistance. Because if you're seeing people coming back time and time again, you may think, oh, they've just gotten reinfected. But in fact, they're probably not reinfected. They probably have a resistant strain. And people started responding to this alarm, but we were all behind the curve. It was really too late. And so in August, the CDC came out and said, sorry, we're done. All we've got left is this one injectable. And you're going to have to start telling your folks to come back. You're going to have to start doing tests for resistance. You're going to have to start giving them injectables, which means you need a certain degree of trained, expensive staff to do it. And you're just going to have to start changing the structure of how we control gonorrhea in this country, which means it's more expensive at a time when every state is needing to spend less money on healthcare. It's really problematic.
I have a question because it's been a while since junior high health class. What happens when you can't treat gonorrhea?
One of the reasons why gonorrhea and syphilis kind of dropped out of public attention is because we didn't think of them as that serious. And we didn't think of them as that serious in part because they were so treatable, but also because we didn't think of them as, oh, this is something that is going to kill you in the way that HIV kills you. What gonorrhea does, if it's not treated, is it slowly infects a bunch of different things in your body. The most important effect is actually for women. Gonorrhea can be a sort of silent infection in women. And if it goes untreated, then it produces pelvic inflammatory disease and infertility. And beyond that, it also creates a number of other infections and inflammations down the road, which are serious for men as well as for women. But the sort of big kind of first line public health effect of untreated gonorrhea is widespread infertility.
Well, that's awful. Okay, well, you know what? Since we're on this topic, let's talk about more awful medical things. Maggie, so you wanted to talk about how Catholic hospitals in the United States treat patients who are suffering from miscarriages. So maybe just give us some background on that.
Yeah, so earlier this year, in October, I think October 28th, Savita Halappanavar died in the hospital in Galway, Ireland. She was pregnant, she'd had a miscarriage, and because the miscarriage had not completed itself naturally, sometimes you have a miscarriage and you have a pregnancy that's going to end, but it doesn't completely eject the fetus fast enough, and you can get an infection if that happens because you have your cervix open. And that basically means you have a pathway for all the bacteria that live in your vagina, that live in a hospital, to kind of work their way up into your uterus. And your uterus is basically the end of the line for a ton of blood vessels, which means that those bacteria that get into your uterus can pretty much get into your bloodstream. And you can end up with septicemia, which is blood poisoning, essentially. You've heard it called that before, and it's essentially an infection that can travel all around your body. And she was killed by septicemia, but she might not have been. We don't know exactly all of the details on this, but she might not have died except for the fact that the hospital that she went to in Ireland wouldn't complete her miscarriage, wouldn't give her an abortion, basically, because the fetus's heart was still beating. Even though, this pregnancy was going to end, she was far too early along for the fetus to survive outside of her body, but they wouldn't complete the miscarriage, they wouldn't give her an abortion because the heartbeat was still there. And that was just such a horrible story. And I wanted to kind of find out a little bit about what kind of policies we have here in the U.S. in Catholic hospitals, because there are a lot of places where, Catholic hospitals are the only hospital you have access to.
Right.
And I was kind of curious about what their policies are on this, what they actually do on this. And so there are a couple of people that I talked to. One was Lori Friedman, and she is a medical sociologist at University of California at San Francisco. And she's been doing these, fairly anecdotal studies, but they're going around and interviewing people who have been doctors, medical personnel at Catholic hospitals about their experiences in these situations. And she's collected stories of not times that got anywhere near as bad as what happened in Ireland. So I spoke with Sister Carol Keehan. She's the president and CEO of the Catholic Health Association of the United States. And what I found that was really interesting is that the policies that the Catholic Health Association has don't necessarily line up with some of these experiences that people have had in individual Catholic hospitals. Because what she told me is that, if a pregnancy is definitely going to end, and they're not at the point where the fetus can survive outside of the body, it doesn't matter whether there's a heartbeat or not. In a Catholic hospital in the US, they'll go ahead and end the pregnancy.
Right.
Which I did not know, and which didn't line up with some of the experiences that people had had at some of these hospitals. And so there seems to be a bit of a disconnect in some ways between what the Catholic hospitals as a whole say they're supposed to be doing and what's actually happening in some individual places. Another really good example of that is she also told me that it's actually official Catholic hospital policy that they'll give the morning after pill to people who've been raped. Which, yeah, I had no idea that was something they were okay with doing, and that's absolutely something they're okay with doing, apparently.
And this is interesting to me because as tragic as this story is, it's definitely provided the opportunity to talk about the ways that science informs healthcare decisions. So have we seen that conversation taking place around this?
Not around this particular topic, I don't think. And I think in general, we haven't had a lot of good discussions about this with women's healthcare. And partly it's just because there is so much we don't actually know. My own doctor, who's an amazing doctor, he does a lot of real heavy evidence-based practitioner. His phrase to me was that, very quickly when you're talking about things like miscarriage and reproductive health, you move very quickly past evidence and into voodoo.
Ooh.
because there's just so little that we know. I mean, uh, even what we know about how frequent miscarriage is mostly estimation. Up until I think the 1980s, we were like we thought it was so much lower than it actually is, like 15% maybe of pregnancies ending in miscarriage. And the only reason we thought that is because those were the ones that got reported. And when people actually sat down and finally did studies of I believe it was like cadavers of women to see like who was pregnant and all these kind of things, what they found was that the miscarriage rate much higher. And particularly if you're talking about miscarriages that people might not even notice and might just think were a slightly late pregnancy, the estimations range from 50 to 75% of conceptions. And so it's just so much that we don't know about what's going on in women's reproductive systems.
I would wonder if we know about more now because of that you can test for pregnancy so very early. You know you're pregnant at 3 weeks, and then you no longer have the baby. Before, that would have been seen as maybe a weird menstruation or something.
Absolutely. That's something that happens. I mean, that's something that's definitely happened. It's made us a lot more aware of what's going on with that.
I want to be sure that we don't lose the policy piece of this discussion, as important as the science of very early pregnancy is, and I think it's incredibly important. It's reassuring to me what Maggie heard when she talked to the hierarchy of Catholic hospitals. But we need to be clear that the lessons of that, what the hierarchy thinks is its policy, is really not percolating down through all the layers. I mean, that happened in
Right.
the Irish case that started this. The Ireland, a very Catholic country, has an exception for a life of the mother exception. And when a fetus is not viable, and the argument was made as this poor woman was being treated, this fetus is not viable, even if there is a heartbeat, and this woman is in danger of death. She actually is reputed to have said to, she was a practicing Hindu, and she was an immigrant living in Ireland. She was and actually a medical professional. She was a dentist. And she reportedly said to her doctors, this is a report from her husband, I'm not a Catholic. And they said to her, it doesn't matter. This is a Catholic country. We have to go by this. Well, similarly, in the United States, where Catholic healthcare is expanding more and more into areas partly through closures and partly through acquisitions, and mergers, so that, as Maggie says, Catholic healthcare may be the only thing available in a particular area, particularly an underserved area. It may be the policy up at the top level, but the policy within healthcare isn't necessarily the policy in the church. And this is not a hypothetical for me. There was a case in 2010 in Arizona where a married woman who already had a number of kids, came in with her 5th pregnancy, very early in pregnancy, about 11 weeks, and had profound pulmonary hypertension. She was in danger of death if the pregnancy continued. The hospital, a Catholic hospital, convened its ethics committee, and the head of the ethics committee, who is both a nun and a degreed nurse, signed off on allowing this woman to have an abortion to save her life. They chose the life of the mother over the life of the very early non-viable fetus, as a result of which that nun was excommunicated by the bishop.
Yep.
And has never been restored. So there's a position, a situation in which that nun, Sister Margaret McBride, not only behaved in a way that we would all think is ethical and humane, but also behaved in accordance with what Maggie's been told is the policy throughout Catholic healthcare, and yet the male hierarchy of the Catholic Church outside that hospital contravened what healthcare policy was and punished the healthcare provider. So, this gets it's. I'm not disagreeing with what Maggie heard. What I'm saying is that it's there's a lot of complexity and bureaucracy and politics in this that still puts healthcare, and particularly women's healthcare, at risk, no matter how clear they may think they're not.
And that's actually something that Sister Kian acknowledged, is that there is when I was asking her about Laurie Friedman's studies, and if this is what your policy is, how do these things happen? And one of the things that she was saying is that sometimes people don't always understand what the policy is. There could really be situations where you have staff who is thinking more about what they're interpreting of the church than what they're interpreting of their own policy in the hospital, and applying it in different ways. She actually said that when it comes to something like tubal ligation, there is a lot of diversity among Catholic hospitals in terms of which ones will allow you to have a voluntary tubal ligation and which ones won't.
You are apparently listening to the most depressing news of 2012 on Skeptically Speaking. We're talking about science stories of 2012, and my guests are Brian Switek, who writes at National Geographic, Maggie-Koerth-Baker, science editor at BoingBoing.net, and Maryn McKenna and David Dobbs, both from Wired.com. David, that is a tough act to follow. Tell us about the DSM. It was recently updated, and you wrote a piece about it for Slate.
The DSM is the Diagnostic Statistical Manual. It's put out every few years by the American Psychiatric Association. It's a guideline for diagnosing mental illness. It sets out a bunch of sort of decision trees that clinicians are supposed to use to decide whether or not someone has depression or something else or isn't ill at all. It has tremendous influence around the world, particularly in the United States, on whether people get diagnosed and what they get diagnosed with, and also on a whole array of social services that might become available to you at schools and elsewhere because you have a certain diagnosis. So it's a very consequential book, and they've been working on the DSM-5, the 5th edition, for over 5 years now. It's been really a torturous story all along, and they had promised early on, unfortunately, that this would be a paradigm shift in how we diagnose mental illness.
Right.
But there's been no paradigm shift in the science of what causes mental illness. There have been a lot of incremental things, but no paradigm shift so that we can have a whole new way of diagnosing things. And this is sort of related to the genetics, whole genome story, in that, there's been tremendous advances in both neuroscience and genetics over the last decade. And I think psychiatry was hoping that those would answer their questions, but they've not. We still don't know why many mental illnesses crop up. So it's not a paradigm shift. Instead, it offered some tweaks and new wrinkles to existing diagnoses and a handful of new controversial diagnoses that have enraged a lot of people. It shrank the definition of autism in a way that has implications that aren't quite clear. It made it easier to get diagnosed with depression in cases where you had recently had a loss of someone close to you. There used to be an exclusion. You were encouraged not to give someone a diagnosis for depression if they had recently had a death by someone close to them. That exclusion has been essentially removed, and now it will add to what many people think is already a trend towards overdiagnosing depression. They also created a new one called disruptive mood dysregulation disorder, which was originally called tantrum something disorder. And this is for kids, and it's one based on how often a kid has temper tantrums and how grumpy they are in between and how violent the temper tantrums are. And this has come under huge criticism, both because it seems like another way of medicalizing normal behavior and because the science behind this diagnosis is just terrible. And binge eating, some other things that they added. Some people look at this, like Alan Francis, the person who directed the DSM-4, he thinks that psychiatry has completely lost its way and that the APA should no longer be in charge of this, have the kind of power they do with this manual, and that essentially it's surrender to all the many forces that encourage overdiagnosis. And there's all kinds of methodology problems. They rushed the studies. They left out a whole slew of second field trials of these things. There's a lot to criticize here. And I think most of those criticisms are on target. But the real problem is that simply it didn't scale back. I mean, defenders of this say it's not that much more expansive than the DSM-4. And essentially that's accurate. But at a time when more and more people, including lots of psychiatrists and psychologists, feel that psychology and psychiatry has really gone way too far in the direction of medicalizing behavior that's within, the main bell curve of behavior. The paradigm shift that the DSM should have had was a clear effort to scale back the criteria of diagnosis of many of these things, particularly depression and anxiety disorders, so that we started diagnosing fewer people and stopped medicalizing so much normal behavior. I'm more and more thinking that's the only thing really that would have cured it, because the handful of grotesque expansions here in this new DSM, along with the failure to scale back other things, seems to send a message that overdiagnosis is okay. There's nothing to fix here. We can keep doing what we've been doing.
David, I was wondering, who are the people that put together the DSM, and how do they end up with those positions? Is it an elected thing? Is it, how do these people get in this power?
It's a complicated thing, and I don't know all the details, but the power structure of the APA, and this is the American Psychiatric Association, not psychological, they end up appointing one or two chairs to direct the assembly of each new edition. So this tremendous power falls to a couple of people who are beholden to a board above them, but are given fairly free rein in their brief. So these people then they created a whole bureaucracy of this. They assign committees that oversee certain areas, and within the committees they assign work groups that will work on particular diagnoses or groups of related diagnoses. And these, at every layer of that, you have a mix of researchers and clinical people, psychologists, psychiatrists, and psychologists, who create these work groups and try to come up with a set of diagnoses, refine existing diagnoses, and answer the question, is there anything we're not addressing properly? Do we need a new diagnosis? And the goal in each case, because they have no biomarkers, we can't point to a brain scan or a blood test or anything like that for any of these, or a genetic test either. So the goal is to create diagnoses that will identify a disorder, which is created when they create the diagnosis, that compromises a person's life or function. And the criteria are supposed to be such that if you take 10 different clinicians, they would look at a given person and agree that this person did or did not meet the criteria for whatever the thing is.
You're listening to Skeptically Speaking, and we'll be right back with more Science in 2012 after these messages.
On the next episode of Skeptically Speaking, we'll listen back to an episode featuring some of nature's most accomplished materials scientists and the amazing substance they produce. We're joined by Leslie Brunetta, co-author of Spider Silk, Evolution and 400 Million Years of Spinning, Waiting, Snagging, and Mating. And science writer Ed Yong tells us about silkworms with spider genes and the hybrid silk they spin. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm Desiree Schell, and on today's episode, we're taking a look back at science in 2012. With me today are Maggie-Koerth-Baker, author of Before the Lights Go Out, Maryn McKenna, who wrote Superbug, David Dobbs, author of Reef Madness, and Brian Switek, author of Written in Stone. And Brian, you are up, because we need dinosaurs to rescue us from the awful, which is everything else. So tell us about the oldest dinosaur that was just discovered.
Well, it might be the oldest dinosaur, it might not. It's actually a really interesting discovery with a lot of cool backstory, and that's part of the reason why I'm so excited about this. In the 1930s, there was a University of Cambridge paleontologist by the name of Rex Parrington, which to me is the best explorer's name I think I could ever imagine. It sounds like, Rex Parrington, man of science or something, but he was looking through these 243 million-year-old red beds in Tanzania, and he found a lot of fragmentary fossils, and he took them back, and he gave the task of studying many of these to a student named Alan Schureg. Now, when Schureg looked at least some of these, he had an upper arm bone, a humerus, and a number of vertebrae, And they looked to him to either be a really early dinosaur or sort of an archaic cousin of crocodiles. And at first he wasn't really sure which was which. But after he defended his PhD, he started to become convinced that these particular bones belonged to what may have been the earliest dinosaur. But he never formally published on this. He named them. He actually, wrote some descriptions of them. He named it Nyasasaurus parringtoni, the species name being after his advisor. But he never got around to formally publishing this, and he died in 1997. So along comes Sterling Nesbitt. He's a paleontologist who specializes in Triassic fossils, and he's been actually going back to these same beds in Tanzania and finding a lot more fossils. And so in the process of doing that, he's looking at a lot of these collections that have already been made, and he looked through Schrig's notes with some of his other collaborators, and they decided to finally get around to naming the specimen, because even though it isn't known by very much, there are certain features, especially of the arm bone, especially of the vertebrae that made up the sacrum, or the part that where the hips would articulate, that seem to scream sort of dinosaur or dinosaur-ish. It's hard to tell which one it is without more, but what it indicates is that this is either the most archaic dinosaur that we know of or the closest relative to the earliest dinosaurs. And it was around by 243 million years ago, which is only about 7 million years or so after that huge Permian mass extinction that wiped out about 90% of known species on the planet. So what this is suggesting is that dinosaurs had this really early origin, like right after the disaster. You had this proliferation of this group called archosaurs, to which dinosaurs belong, but also crocodiles and all their relatives as well. So rather than having this relatively late arrival, the previous estimate was around like 230 million years ago. We've actually pushed the origin of dinosaurs back about 12 to 15 million years. So that's a really large span of time to go looking now. Now that we know we've got that span of time, we can sort of look at other middle Triassic localities around the world and say, okay, dinosaurs should be here, even if it's a fragment. Is there anything that sort of would suggest a dinosaur? They emerged after the worst mass extinction of all time, and all of them except for the birds died out about 66 million years ago. So it's a nice little bookend to their story.
Thank you, Brian, for making us feel better with dinosaurs. So one thing that I think we can all talk about a bit is one of David's pet topics, and neurobullocks. David, can you define that term first of all?
Well, neurobullocks is kind of a British term for what we would call neuro BS or neuro nonsense here in the U.S. And one of the things that happened this year, neuroscience has been a big deal. It's really interesting, but it's been hyped, and people have spun stories out of it that weren't terribly well supported by the science. So there's been a lot of pushback on this year, and it's actually taking effect. I mean, you can see this in the behavior of editors and in the flavor of the conversation online and in a broader critical, sober look at news stories offered about how the brain works. And I think this is very healthy because things were getting a little too wild. And perhaps the most notable instance of this year, the pushback, was the reaction to Naomi Wolf's book, Vagina, a biography. The book had a lot of problems. We spent a whole program here on Skeptically Speaking talking about them, so I won't do it all again. But essentially, it wildly oversimplified the good science that had been done on female sexuality and took some sketchy findings done by one researcher and just ran away with them to make an argument about the innate nature of female identity and sexuality and even consciousness. It's been a long time since I have seen a book so roundly battered as that one was. Another instance, which is a little more complex, was that the pushback against neurobullocks came into play in the downfall of Jonah Lehrer.
Exactly.
Who is a very complicated case, and he's a complicated case for me, I'll just say right out, because he was a friend, and I'm not quite clear whether he still is a friend, and he was a colleague of Maryn and I's and Brian's at Wired. An enormously talented writer, very smart, but he had a downfall because he was caught doing a number of ethical boo-boos, naughty boo-boos, like cardinal sins, including plagiarizing and making stuff up. Now, plagiarizing yourself that's bad practice. It's not bad ethics, but he plagiarized other people as well, and he made things up. And these, in writing as in science, those are cardinal sins. You're fired. And he was fired. But when that happened, a lot of people started saying, that as bad as the ethical problems were, the ethical breaches were, a bigger problem with Jonah's writing was how he turned neuroscience into an area of fabulistic lessons, that it was sort of news you could use. And I have some sympathy for that argument, because this, to me, is a lot of the problem with the neuroscience writing has gone much too far in the direction of grabbing a set of findings, which are usually new and often counterintuitive, and building a story on them that sounds very certain. We now know how we make decisions. We now know why we do this or that. We don't know these things. We have new compelling ideas about them that haven't been sufficiently tested yet. Neuroscience is extremely early in its maturational cycle. When I was at the neuroscience meeting last year, I was at a table about 8 or 10 neuroscientists, and I asked, so, on a scale of 0 to 100, and 0 is we know nothing about the brain, and 100 is we know pretty much everything we need to know about every major system of the brain to explain just about any behavior, mood, thought, etc. Near perfect actionable knowledge. Where are we on this scale? The answers were almost all in the single digits. One person kind of boldly, apologetically said 13 out of 100. So this is how early we are in this field. There's a few things that we can say with certainty, but there are very few, and they don't pop up every month. So this trend where we're constantly throwing out these studies and saying that they explain this finally, it really needed to be pushed back, and it has been.
And this is really what I want to talk to the rest of you about, because how do you navigate as science journalists in this kind of area? How does it affect you and your field when someone like perhaps Jonah Lehrer or whoever mucks it up so very badly? Because does it affect journalism? Does it affect the field that you're writing about? How do you guys feel about that?
One of the things with the Jonah Lehrer case in particular is that I find that my friends who are not science journalists don't understand that anything really happened.
Right.
And don't understand why people are upset about him, and I actually had to explain the neurobolic stuff to a friend recently who read Imagine and loved it, and were like, well, if it's just a couple of, bad Bob Dylan quotes, I can still get something out of this, right? And I'm like, well, maybe, sort of. We have to kind of talk about this neurobolics thing, and I really don't think that the general public understands it. One of the things that I thought was really interesting is that this year in the Ig Nobel Awards, one of the prizes went to a study that used fMRI on a dead salmon, frozen salmon, and actually found signals, measurable signals coming through the fMRI from this frozen salmon. And I put up a post on BoingBoing kind of talking about this, because there are a lot of times when you can get, data that isn't necessarily useful data out of these techniques. And I don't think people understand that at all. I think people look at these pretty pictures that come out of the brain and they think, well, that is showing me exactly what's happening, and it's showing me something, absolute. And that's not necessarily true.
This issue of interest in and alarm over something moving ahead of the facts, which may change, is an edge that I live on all the time as somebody who writes about emerging infections. And there's a great example going on right now. One of the big infectious disease stories of the year has been this new virus that emerged, it turns out now in spring, but initially we thought in late autumn, in Saudi Arabia and Qatar, and has been slowly expanding. First we knew of one case, then 2 cases. Now we're up to 9 cases and 5 deaths. It's a virus that's related to the SARS virus, which 10 years ago swept the world in a couple of months, sickened more than 8,000 people, killed almost 800, shut down several countries, including the city of Toronto, ruined the GNP of the Pacific Rim for about 6 months. And as I've been reporting on this piece by piece, people want to hear oh, this is just like SARS, and therefore we should prepare, or no, it's going to fizzle out, and keeping people in a spot where they can entertain both possibilities for an emerging infection or a third possibility, and staying open to all of those and being appropriately prepared but not either terrified or dismissive is a balancing act that I think I probably still have not mastered despite years of doing this. But the lack of comfort with unknown unknowns and the need to seek some kind of certainty and then to be disturbed when the certainty turns out to be wrong is the space I live in most of the time.
Well, I was just going to say, you scare me constantly, but it's like a warm blanket of fear, Maryn, if that helps.
Picking up what Maryn was saying, I think that there's, and to tie this back to the Journal Era thing also, I think there's also a lot of pressure on science journalists in particular to tell people absolutes and to present ourselves as experts on things that we're not really experts on, we're translators on. And it's really easy to give into that pressure, and you have to kind of fight against that a lot.
I mean, I don't encounter, sort of the same variety of neurobiologics. I guess I deal more with paleobiologics more than anything else. But it's a very similar pressure, especially when writing short news pieces. When you have, 500 words at maximum about a new study, and the focus is on results. What's new? Tell me why, tell me what this says, and give me an outside opinion from another researcher saying whether it's true or not. And in that, the sort of process of science gets lost. I mean, it's something different than neurology or neuroscience and genetics. But with paleontology, I mean, one of the reasons why I just wrote the book that I wrote is because people are not used to sort of the new imagery of prehistoric life. When you add feathers to a velociraptor and people say that's terrible. Well, we have really good evidence that that was the case. But we're not really explaining how we know the things that we know, the process of science, how messy it is, how we test ideas. When we get really results oriented and try and make it so accessible that someone can immediately take that little nugget and apply it to their lives, especially in things like neuroscience and evolutionary psychology and things of that nature, all that gene 4 stuff that we get snit about so often, rightfully so. It would be great if that kind of writing can go extinct, and that's something that I try and be conscious of as a journalist is, am I conveying the messiness and open-endedness of this process well enough?
It's really hard. I mean, the gene 4 situation, to clarify for listeners, this is the frequent appearance of stories that say they found the gene for X being something very complicated, like any behavior. So this happens all the time, and it's narrowed to a single gene. And it's one finding that gets overplayed and ignores the fact that geneticists know that any complex behavior or trait arises from multiple genes, almost always. So this is something that we face constantly, and that I think we are starting to see an effect. I have a story that came out a couple of days ago in the National Geographic about what are the genetic roots of our compulsion to explore. And one story about that has been that this one gene variant, DRD47R, accounts for much of our curiosity and urge to explore. And I think 3 years ago, I would have come under tremendous pressure to make my story about that gene. As it is, I was able in this story for the National Geographic to look critically at the idea that it boiled down to that one gene and to make it clear that it's not going to be one gene. That gene might play a role, but this is going to be a complex array of genes that we don't have the capacity to identify yet. So we have to look at richer, more complicated ideas about how genes, our genome, can lead to this exploratory urge. So I think this pushback is actually working. It's affecting the behavior of some editors and allowing us to write richer stories.
And allowing us lay people to get the most accurate, up-to-date scientific news. And we are out of time. Thanks very much for being here, guys.
It was a real pleasure.
Oh, thanks for having me.
Thank you for having us.
You'll find links to Brian Switek, Maggie-Koerth-Baker, Maryn McKenna, and David Dobbs on our website at skepticallyspeaking.com. While you're there, click the links to Twitter, Facebook, and Google+, where you can keep up with show news, and to iTunes, where you can subscribe to the podcast, listen to past episodes, or leave a review. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our studio assistants are Helen Cavillion and Chelsea Butler. Ryan Bromsgrove is our studio technician. The show is edited by K.O. Myers. Our theme song was written and recorded by A.OK. And I'm your host, Desiree Shell.